Hey everybody, it's the Brothers WISP number 35. You've got me, Greg Soul. You've got Tomish. Say it the right way. Do it right for us, Thomas.
Tomas Kirňák.
All right, it wasn't going to happen. Wasn't going to happen. Thomas is coming all the way from Slovakia. Lovely, lovely Slovakia. What's the weather like right now?
Uh, it's getting colder. Winter is coming.
Gotcha. You've been watching a lot of Game of Thrones. Alex Hart from
Hello,
Oregon. How are you, sir?
I'm doing well, thanks.
That's lovely. Awesome. Well, this week was WISPAPALOOZA over in Vegas, and these are the three losers that didn't get to go. So we're going to pretend like it didn't exist because we hate everybody who did go. And they're all too hungover and or broke from the casinos to jump on here, so we're just going to pretend like they don't exist. They're dead to me. Absolutely dead to me. So first on the agenda today is Thomas actually went to the Budapest MUM. I think it was the 7th, right?
It was the last Friday, so whenever that was.
Yeah, I don't have a clue. And so Thomas was there with Unimus, the lovely, lovely Unimus. How was the show?
It was actually much more people than I expected. I expected to be like the usual micro mums, the little one-day mums with 200, 100 to 200 people maybe. But there was solid 600 to 700 people, which I was really surprised.
That's crazy. That's like the entirety of the U.S. MUM's attendance or better, right?
Yeah, even more than the usual US mums. Yeah.
There you go. We need to step up our game. It's ridiculous.
I know, right?
That's cool. Did you get to meet a lot of new people? See some new faces?
So the most people there actually were Hungarian, since the mum was supposed to be officially just a Hungarian one-day mum, but there were people from all over. Yeah.
Very cool. So there is also some Unimus news. You are officially in open beta now, right?
Yes, we entered open beta. Actually, we released open beta just one day before the Budapest MUM, and just yesterday we released also a new version to go out with the open beta.
All right. So what does that mean to everybody listening? What does an open beta mean?
Basically, you can just sign up. We now have a user management portal, which is at portal.unimus.net, and you can create an account yourself, and it's now freely and publicly available to download and try. But we are still just advertising it as a beta version, so
Gotcha.
it's not full release quite yet.
There's some new updates recently, right? Like some radius integration and some other goodies.
Yeah, we integrated Radius, which was in the release yesterday, which I am very happy about because, as you guys probably know, I usually complain a lot if things don't have Radius integration. So now I at least don't come out as, well, you don't have it either. So now we have it as well, and support for Cisco stuff and other things, other vendors and devices.
Gotcha. Ever adding new devices. That's awesome.
Always.
Cool, cool, cool. All right, so moving on. I can't remember who put up the link. I think it might have been Andrew Cox. Should I block ICMP.com, which I thought was pretty cute. So if you ever run into a troubleshooting problem where somebody's blocking ICMP, you can send them this friendly link. And at the very top of the page, should I block ICMP? It says no. And it runs through the laundry list of all of the tremendous things that ICMP is capable of doing and how it can help you. And I think it also kind of echoes back some of the things that, you see what I did there, a little pun.
Well, it only echoes back if it's enabled, right?
There you go. But it also tells you some of the reasons why you wouldn't want to do that. You guys would never block ICMP, right?
No, never.
I say rate limit ICMP, protect your devices from being overrun, but I loathe when I get troubleshooting calls for people. It's usually people doing like payment gateways or things like that, right? Super secure folks, they'll block ICMP, right? They don't want anybody to know their equipment exists on the internet, and it just makes troubleshooting impossible. Excellent. Well,
How do you feel about let's say you're running a pretty strict firewall where your default is just to drop things, and maybe this isn't for your traffic out to the internet, but if you're only opening certain ports to a certain IP address, would you rather have ICMP be part of that so that you can see that the some traffic is open to that box, or do you feel like that can be blocked?
For me personally, say that was a requirement for you to be uber secure, right? Maybe a workaround is you put a port knock script on there so that the ISP, the guy actually doing the troubleshooting, can port knock really quick and then be able to test freely through for some certain amount of time, right? And so I don't know if that would be an ultimate sort of compromise. A port knock is basically where you send either a TCP, a UDP, or ICMP, some special sequence of requests to an end device on specific ports. It's basically like a key and tumbler, right? So first it'll be TCP port 111, and then it'll be a shot at UDP 60, and then that will add you to an address list that lets you, say, do ICMP for the next 20 minutes, something like that. What do you think? Would that be a decent compromise?
I don't know. I know some of the arguments there is detecting MTU and things like that. So
I was gonna jump in there and say it's ICMP does much more than just letting you do ping, right? So much more than just that. And even in networks which you want really to be secure from the outside, you usually have outgoing traffic. And even then, even blocking ICMP is not security, it's obscurity. And there is a huge difference between security and obscurity, right? And just getting rid of the ability to have automatic path MTU discovery it's just a huge pain, and it breaks so many things.
Sure.
You know, and most of the stuff I see today, like compromise tips, it doesn't necessarily start with an ICMP. They'll just start port scanning and see what's open. So what does it hurt to have the ICMP open?
If you are a payment gateway, or if you are a web server, there is a myriad of ways to find out if something lives on that IP address other than just ICMP. If somebody really wants to find out if an IP address is alive or not, blocking ICMP will not help as soon as you have any inbound services at all.
Sure.
True story. I guess theoretically, if all of your customers, all of your clients had static IP addresses and you just allowed traffic specifically from them, like Alex was saying earlier, you could kind of fly stealth and pretend like you didn't exist to the rest of the internet. And that's great and all until you have a problem and you need anybody else in the rest of the world to troubleshoot it. And then you're handicapping them, you know.
Sure.
But still, again, that's only about ping.
Yeah.
When you do that, you lose so much more of the things that we talked about previously.
Yeah. Like you were saying, fragmentation, right? If you hit a router and the MTU, the maximum size that's allowed through that router, is smaller than what your packet is, it'll drop that and it'll send back a special ICMP message that says, hey, you need to readjust, right? And that's a very useful thing. And you could be handicapping people on your network from doing things like that.
And it's not just that. For example, even IPv6, in IPv6, ICMPv6 is completely required. Just IPv6 doesn't work without ICMPv6. So if you look into the future as well, IPv6 is even designed in a way that you have to have ICMP. So you can see that it's it's not just something that we say. It's the entire next IP protocol is based around ICMP. So it's so important that even in IPv4, you really shouldn't disable it completely, never.
Yeah. So like IPv6 gets rid of the concept of ARP, right? ARP doesn't exist anymore, and they substitute some special ICMP stuff for that. So
it's actually ND, neighbor discovery.
Yeah, there you go. So it's absolutely required in that instance.
Bottom line, if you are going to have even a drop-all firewall, make sure you put something up at the top to allow ICMP. And if nothing else, you can rate limit it, but you should be allowing that through across the board.
At least for my sanity, please.
Mm-hmm.
And actually, in that link, should I block ICMP? If you want to be really, really secure, there is a list of specific ICMP codes that you really should allow. So if you don't even want to allow full ICMP, at least allow the specific ICMP codes which are required for path, MTU discovery, and stuff like that.
Yeah, all the good stuff. You know, I think it's funny. What has it been? 3 decades, and we're still basically using the exact same tools, you know, ping and traceroute, to do all of our troubleshooting, or the vast majority of it. There's a couple other things that we use, but 90% of the time, that's my go-to.
Sure. Keep it simple, right?
I guess so. It doesn't help you troubleshoot advanced services. That's where other things come in, right? So that kind of segues into something else I ran into. So I was just trying to think of what are a couple of things that popped up this week that would be interesting to talk about since the WISPAPALOOZA guys are dead. One was Wireshark. So oddly enough, it's a payment processor that I've been having problems with, and they've been saying, hey, you're blocking our traffic in your firewall. And I knew for certain that all traffic sourced from this user, I mean, they're going through a NAT device, right? So they're RFC 1918, private address inside. When they go outside, they NAT, and it's allowed to come back in. And so we're filtering nothing outbound. And then once it establishes that connection, it's allowed to come back in. So I kept telling this guy, we're not blocking anything. And they kept saying, well, these transactions are failing because you're blocking in your firewall. And since it's a payment processing server, I can't log into it. I can't touch it. You know, we have no visibility into it, so I just have to take their word for it. So in that instance, you know, what do you do? So what I did is I used the Packet Sniffer tool in my Mikrotik router, which allows you to do packet captures, right? So I said anything to or from the payment processor IP, capture that, saved it as a file, dragged it, dropped it on my desktop, and popped it open. So immediately I see a TCP three-way handshake happen. I'm like, well, obviously there's bidirectional traffic, you know, it's going through. And then I see the client machine on our side attempt a connection out, and then it acknowledges it, and then it waits, and then it sends a fin, right? So it's closing the session. And it waits 10 seconds exactly. And so I'm thinking, well, okay, it looks like the client timed out. So I tried SSH from that router because they have it open, and it took 31 seconds before it replied with a password prompt. So I killed it, opened it up again, took 32 seconds. And so I'm talking to the guy, and it's their software, and he's been telling me for 2 weeks that it's our firewall. And I said, well, I attempted connection, and it's taking 30 seconds. You're timing out in 10 seconds. You think you can adjust that timer? And he's like, let me look, and then goes back and forth. They were able to adjust it to 15 seconds. I was like, it's not even close. Can you see what we're doing here? And so without Wireshark, I would still be under the gun, right? So this payment processor, it had been batching jobs for so long that it stopped. So in essence, this customer was having to let people, it was a parking lot where they charged for people to come in, so they were having to just open the gates and let people come and go. So they stopped making money all of a sudden, so it became very critical. And I was just trying to imagine how else would I have figured this out, because they were just, I mean, they were entirely happy with telling me it's not our problem, it's your problem. And they were absolutely not going to look any further until I could provide some concrete evidence that was their problem. Do you guys have any way that you can think of that you would have proved without a, you know, to some reasonable degree in this instance like this, without doing a packet capture, that it was their software?
It depends on the implementation of the payment processor client. For example, the payment processor that we use for Unimus, we actually use their own SDK, and their own SDK would tell you if something like that is happening, right? So since the SDK, the piece of code, is the payment processor, you just tell them, you know, your SDK is giving us this error, you provide them a stack trace, and there you go. So it depends on, because you can obviously go at it from either upper layers or lower layers.
Yeah.
In the end, right, if you go all the way down to a packet capture, again, it depends, because, for example, depending on the kind of an issue, it wouldn't show you an issue in application logic, because at that level, it's usually TSL, right? It's encrypted. So, for example, you wouldn't see a different issue, like a difference between SDK versions or the communication protocol to the server versions and stuff like that. So, yeah, it depends.
Yeah. So for us, this credit card processing server is a black box. And then there's the gate people's server that sits right next to it, connected to the same switch, and it communicates over. And all it knows is it's not processing it. That's the extent that they could tell us. It's not processing those cards. I'm sorry. And the processor was just saying, hey, our stuff is working fine. And so whenever it was going to validate one of these credit card transactions, it would create that SSH tunnel out. Or in this instance, it would try, wait 10 seconds, and then kill it because it was never establishing. And so we couldn't log into it. They were telling us everything was fine. So basically our hands were tied at this point. And so I don't know that I had any other way, right? I mean, you as the developer of Unimus with the SDK and all that stuff, you obviously have deep visibility into the application, and these guys theoretically did too. But
was the actual client to the payment processor, was that a black box for you as well?
Yeah. Well,
was that a hardware appliance they were using, just a card swiper? Or did they have software running on a computer that was connected to that server?
It was so the payment processor was a server. The gate software was a server here that ultimately went back to a card swipe. So they'd swipe the card, it hits this server, the server just passes the transaction over to the processor's little server here right next to him, and it would just say it failed. That's all that would come back. It wouldn't say, hey, I timed out trying to connect to the server. And what's funny is I had the payment processor guys log into their server and watching it while we were doing transactions, and it apparently wasn't spitting any debug message saying, hey, my client timed out. It just says, sorry, failed to make the connection, so you guys are blocking it in the firewall.
The good old logs show nothing.
Yeah, and it's just, it perplexes me that it's their software, they entirely own it, and I have to go to these crazy degrees to get them to agree that, yeah, maybe there is something wrong with what we're doing here. Once we got that figured out, they got with their developer, and they said, he's out right now, so we'll have to wait for him, which makes me wonder if there's only one guy. But ultimately, they got it resolved magically. I don't know what they did, and I kind of don't care. Just the fact that they quit blaming me, which was really nice. But yeah, so for me, having that Wireshark, or rather the packet sniffer capability built into the Mikrotik, was invaluable. Because it didn't matter where I was, what time of day, because I ultimately ended up doing some of that troubleshooting really late at night with their support on the phone, and there was no way I wanted to sit out there at that remote site, jacking around with this stuff. So it kind of put all that control back in your hands, which I thought was really awesome. This is it's not the first time I've used it, but it's been a little while since I've had to actually go to this degree, and man, I sure was proud of that feature.
I would say, short of being able to sniff the packets and do a packet capture, you probably could have gone into the connection tracking table and seen the connection go from a initial state to an established state. That wouldn't have helped you with them, but you could have for yourself seen that, hey, there's a handshake going on here, and the connection's transitioning into an established state. So it's not the firewall.
So
but I think I agree with you completely. It's invaluable to be able to take the packet capture and provide that to somebody else in a universal language that they can look at and go, oh yeah, there's definitely a thing.
Well, before I actually did the capture, I created a firewall rule looking for anything going out to that IP or coming back, and then they create a log entry. And that gives you source IP destination, right? So it gives you imports and all that stuff, and kind of gives you the timing. But as you said, being able to actually look at that PCAP, make notes, send it to them, and say, hey, this is what I'm seeing. Again, in that universal language, that they could open it right there and see for themselves. I don't know that. Well, I sent it to them, and they said they didn't see anything wrong, and then I made some screenshots and circled some things and said, look at this part. And they said, oh, okay. So I guess you still have to know what you're looking at.
I've used the same technique, both with saving a capture to disk on the Mikrotik and also using the live filtering and mirroring to an IP. So you can actually open up Wireshark and send all or just filtered traffic to your Wireshark client directly in real time, without having to capture it, download it from the Mikrotik, and then open it and save it. Of course, you can also save directly from Wireshark at that point, either the whole capture or just it's pretty good about letting you filter down and then just save the filtered packets. And I've used that a ton. One of the things I've used that for is the Mikrotik IPsec hardware encryption driver problem. I actually was able to use their own tool, do a packet capture, and show them how all of the packets were being sent out of order. And there's also a lot of other tools in Wireshark for graphing how many packets are out of order or how many packets are being dropped, or all these things, and to be able to not only provide them with those captures, but to use the tools that Wireshark has to kind of analyze the data and also provide them with that to say, hey, there's obviously a problem here. People respect that a lot more than you just saying, oh yeah, I think there's some things wrong, and no, it's not on my end, it's on your end, it's not my firewall, or whatever the case may be. So
you haven't had to use that with your own developers, have you?
I haven't, no.
Okay, I was just curious.
But I've also used it with a vendor that said, hey, like, we don't know what's going on, we're not getting your connections, and to be able to do that capture and look at that together and say, all right, what's going on here?
Yeah.
Oh yeah, it looks like you didn't get our IP in your whitelist address. That's the problem why we can't connect.
Yeah, I've used it for stuff too, like proxies. Like I had a proxy go bananas one time, and there were some certain URLs that it would kill, and the vendor kept assuring me that it wasn't the proxy, and the website, if you did a trace route to it, was 30 milliseconds away. And so when you do the packet capture, the proxy on site, you would see it reply back in about, I don't know, 1 millisecond. And I'm like, so physics dictate that it's not your website refusing the connection. It's this proxy right here because it's too fast. And they're like, oh, yeah, our bad. And then they got in there and fixed it, right? So it can help you in a lot of different ways, unexpected ways.
Sure.
And again, I don't always know what I'm looking at, but I can read the time on the side to see how long it took packets to do what. So,
and there's so much data there, and Wireshark does such a good job at letting you deep dive into every single packet. And they've got so many built-in filters and tools to analyze so many different protocols and things that, yeah, it's invaluable.
Yeah, crazy awesome. All right, you have any further comments on that one, Thomas, before we stick a fork in it?
Oh, I mean, pretty much anybody that's ever debugged SIP without Wireshark and packet capture, that would be just not possible.
Yeah, there's like a whole tab that says like VoIP or whatever, and then or telephony, I can't remember, and it just will break down the call and show you both sides.
You can even play back the audio if it's not encrypted.
Oh yeah, I'd say anybody that's using level 3 SIP services, this is your best friend.
And you can do captures at different parts in your network, maybe at the client, at your edge. Maybe you can get one from your different provider, wherever the call is coming from, and you can analyze it and say, okay, well, where is this delay coming from? And so sometimes having that at multiple points in your network is really helpful too.
It's actually one of my favorite features in Wireshark in general, that you can reconstruct any sessions and actually see data on sessions inside of Wireshark. Just from a packet capture, you can actually analyze the traffic on the sessions even at higher levels, and that's sometimes extremely useful as well.
Yeah, I love being able to see it and then follow stream, and it just pulls all the relevant packets together.
Right yeah, exactly.
You mentioned adding radius support earlier to Unimus, and I was a radius sometimes can kind of throw you a curveball, and being able to pull up captures on radius transactions is helpful too.
Don't get me started.
I had this really interesting side effect, I guess. I'd say side effect. Anything bad that happens with my level 3 SIP, that's a side effect, right? It's like the the drug commercials, you know, possible death. I've just had nothing but great success with level 3 SIP. Anyway, I have this problem where occasionally an outside call will come in, and the person on the phone will just hear themselves mirrored back, and the person who answers the phone inside my organization will hear themselves mirrored back. So I ended up doing some packet captures so that you could actually play them back, and you would hear like the person just sitting there talking to themselves, because it was going out to level 3, bouncing back, and so you'd actually see it sourced from their SIP servers. It was like on the little graph where it shows the two conversation sides, it would just be just a slight offset. Blah, blah, blah. So that was able to actually help me convince them that yes, maybe there is a problem with your connection.
Yeah.
And so many times it's, no, there's nothing wrong, sorry. You have to, you know, provide them a smoking gun, otherwise they're just going to keep going. I don't know if you can tell that I'm a little bit salty still about all of that. It's been happening a lot to me lately. All right. So something else, you know, again, just trying to think of things. I was helping a guy out with his BGP configuration just recently, and he had done a pretty good job. He has a ton of peers. I was surprised. He had like 12 or 13 peers, I think. But it was prefix lists. So he wanted me to look at his filters, inbound and outbound, and kind of help him tweak a few things. And one thing I noticed was he wasn't using prefix-length on any of his route filters. So I was thinking, you know, what could go bad by not using prefix-length, right? So in your route filters, you can specify, say, a subnet, right? So 192.168.0.1/24. And then the prefix length is an additional field that allows you to say, you know, within this subnet, it could be, you know, from this size to this size, right? So it makes it a little bit more flexible. And for him, he had his subnets inbound, the /22s, he had them filtered out, right? Which is what you're supposed to do. You don't want your own subnets coming back in. But the unfortunate part of that is somebody else could advertise his address space as /24s, and he still would have accepted that in because he wasn't using prefix links. So in actuality, so at his borders, he was just doing one route for the /22s that were sending him elsewhere. So if somebody had advertised his 24s, he would have actually been routing all of his own addressing, trying to get to that right back out to the internet, which would have been really bad. That would have effectively black holed all of his traffic. So prefix length is absolutely something to keep an eye on inbound and outbound, especially trying to keep out that bad stuff coming inbound. Thought that was interesting. Any words of wisdom from you guys?
No, absolutely. I think that's very important.
No, I know Thomas looks so bored when I talk about the basic stuff. He needs something somewhere. Right.
Well, what can I say? It's like, I concur. I concur. I concur.
Well, I don't know. Whenever I start thinking about route filters, I think about oddities. Like I've heard that people are having mixed results if you, on your BGP instance, the inbound and outbound, if you put route filters there, I've heard that people are having some really spottiness with that. So you probably shouldn't do that. You should put it directly on the peer statements. I've always put it on the peer statements. I've never actually done it on the other one. Have you heard similar things, guys? I think
it was even one of our brothers that had this particular issue. I remember seeing something about it in our chats.
I think it might have been Tom.
I think so as well.
Yeah, he's very vocal about those kinds of things. So there you go. There's a little tidbit for you. Something else that kind of is thought-provoking is the Open Compute project. And I'm not sure if you guys have read about this, and for a lot of our listeners, I don't think it really even factors much into your life at this point. I want to say it was started by Facebook, I think.
Sounds right.
I think they came up with sort of a standard design in their data centers where, I mean, obviously back in the day, you know, in the long ago, in the before time, they were using off-the-shelf hardware, and then they started modifying it, right? And then economies of scale, when you get big enough, you can start telling people how you want things made. Well, that's where I believe the Open Compute project was born. They said, you know, we want these special pizza boxes, you know, to be shaped a certain way, have certain features, to be able to realize a lot of savings. So I think one thing they did was, I want to say they switched most of their server infrastructure to be using, say, DC plants. And at the rack, I want to say they do rectifiers, and it's just DC straight into the gear. And I want to say I heard that they had announced that they're saving billions, or have saved billions, just based on those sorts of things, right? And so a lot of this open compute stuff centers around these servers, and my understanding is it started at servers, and then it eventually went over to, say, SANs, and then they thought, well, we've got to connect the SAN to the server somehow. What about the network piece, right? So they started thinking about the network a little bit, at least, for the Open Compute project, right? And so Open Compute is a published sort of open standard for, here's a hardware design, and any manufacturer can grab it and create these white boxes that people can, just grab and use. So on the network side, supposedly they're coming out with some really high performance, say, switch architecture or route architectures, and the idea being you can grab those and, say, load Cumulus or any NOS, network operating system you want on these things and do whatever you want. And I'm thinking if eventually some really powerful boxes, and we're talking about, 1U pizza boxes that have 100 gig interfaces, not just 10 gig interfaces. Why wouldn't Mikrotik maybe be able to chase that market? I mean, I think I would be pretty interested in, a 24 port or 48 port, 10 gig off the shelf piece of gear that you could load Mikrotik in. Not to say the CCR wouldn't take a hit from that kind of thing. But I think it's interesting. And then something else they were talking about were access points. Why couldn't you standardize access points? And I think packet pushers in particular, I listened to one of their podcasts, listened to them talk about it. And on the AP side, they were saying that what's the difference between all these access points that are being deployed or created by different vendors these days? And it really comes down to the antennas, right? I can imagine that the processors don't really make that big a difference, right? The RAM, who cares about RAM? You can buy it from any vendor. It's going to come down to antenna design and some of the tricks that you use. But wouldn't it be interesting if you could come up with a design that didn't infringe on any patents and that anybody could start spitting these things out? And I know I'm saying Mikrotik to be able to load on those because that's, what we talk a lot about, but theoretically you could do it with anything. What do you guys think? Any thoughts or ideas on kind of an open standard network device?
Well, I think there's been a lot of attempts at getting that right, and I don't know that there's been a whole lot of traction with it. You have all the big players with money that want to keep things closed and tight so they don't have something that's affecting the revenue stream, right?
Yeah.
I also think it kind of comes to just people wanting the assurance and the support and the SLAs that come with vendor boxes. And I don't think vendors would go for providing support and SLAs and tech and services and stuff like that for, even if it's open hardware, it's not their hardware, right? So providing things that they provide now on those services would I don't think vendors would go for it. And big enterprises or even bigger networks for us for providers or transit networks, you just want those services. You want to have that assurance, which I don't think vendors would provide with that kind of a deal.
What about, I think of it also like x86 architecture, right? So it doesn't matter what server brand you buy, even a super micro, if you load Windows Server on there, Microsoft's going to support it to some degree, right? And so why couldn't we get to the, because x86 is the standard, right? Back in the day, there were all different variants of server platform, and it was a very specific operating system you could stick on that platform, right? So you'd buy a server, and a lot of times it came preloaded with your IBM software or your Sun Solaris, whatever it happens to be. And why couldn't we get to that same point with network hardware, right? Where you get a quote-unquote x86 network appliance and you just pick whatever operating system you want on there, and as long as it, I guess, theoretically fits some sort of mold, the vendors would still support it.
Well, you have the usual dilemma today, right? ASICs versus software base and stuff like that, and different vendors do different stuff with their operating systems, and there are different ways to design and architecture networking hardware and then the networking operating system. And I guess I'm not saying it wouldn't be possible. I'm just like Alex said. I don't think like vendors wouldn't take that. They would want to stick with the stuff they have, and you know. I don't think it would be something that the vendors would just easily adopt and easily like, let's go with this.
No, absolutely not. I mean, that's how they make money, right? They create their
Oh,
silicon
exactly.
and they sell it. And they have to differentiate themselves from other people, right? My silicon's better than yours, right? And this is how, blah blah blah, right? But a lot of vendors now are starting to take those Broadcom chipsets, right, and integrate them into their gear. So at some point, you know, all the internal components are going to be pretty much the same. Like, I thought it was funny. I saw Ben Heck do a teardown. Ben Heckendorn, he's this guy who hacks up all kinds of stuff and does cool things. But he makes a lot of portable consoles, right? He'll turn them into laptops or whatever. So he did a teardown of the new Slim PlayStation 4 and the new Xbox One Slim that just came out. And they have almost the exact same processors in both of those units, right? And most of the components are pretty much the same. So those consoles are pretty much the same thing. They're pretty much just PCs, you know, with a different skin. So it seems like the networking world, right? We're starting to see a lot of the same chipsets come out of, you know, granted we see it a lot on some of the lower end stuff, right? So if you look at the chips in a TP-Link versus a Linksys versus, you know, all of those kind of, and probably even Mikrotik to a large degree, a lot of the same chipsets are in a lot of the same, what is it, I think some of the edge routers, it's one of the, I hear so many people say so many things, I lose track. I think it was Thrift was saying the processors in the edge router X's are the same processors that Mikrotik's about to put into one of their routers or something.
Yeah, I think I remember seeing something like that.
Yeah, so even there, right, a lot of the vendors are starting to use so many of the same chips. At some point, I wonder if one of them will just say, you know what, let's go for it. Let's just start spitting out a generic box that anybody can use, right? And I know there's some vendors that do that, right? They have the open computer, open networking, you can load a different NOS on them, but most of those things are really expensive, right? And not to say there's anything wrong with that, it obviously has a place, especially kind of in those really big, high compute, hyperscale data center environments. But what about people like us? You know, maybe, I don't know, Alex has some pretty big chops over there, but a lot of the guys listening to us aren't the kind of guys that can afford to drop, you know, 8 to 10 grand on a single switch. When some of the lower scale stuff starts to come out standardized, I mean, that would be, to me, that's kind of an exciting thing, right? So I could get one box and I could truly apples to apples put everybody's OS on there and see which one I like the best, you know, or see which one's the most stable, or which one gives me the right telemetry, and maybe even customized to different environments, right? I guess that's the promise of the open networking stacks that are sort of being developed right now. I don't know. To me, I feel like the day of the SAN is dead, where you go to an EMC. It's not, right? But I see something new on the horizon, right? With sort of the vSAN idea, where you, instead of going and buying this monster SAN, you just sort of spin up your own ZFS SAN over here, right? And you can accomplish the same thing but save a lot of money. I feel like that promise is maybe on the horizon for networking stuff too. Mikrotik being able to load it on an x86 was huge for me when I first saw that capability, and I still use it, right? That I can take any hardware I want, you know, any hardware. You know, you still run into some driver stuff on the NICs and things like that, but and I can build anything I want, right? Am I a little bit delusional? Maybe.
I think the technology's existed for a long time. I think a lot of people have been using similar hardware. White box is maybe more common now than it used to be, but you miss out on the this equipment can be purpose built, where you take out the added expenses and you make it work for just networking, just for the amount of ports it has. You have the right amount of processing power, and you can slim down how much power it uses, how much space it uses, and provide it at a lower cost, or manufacture it cheaper, right? If you start adding a lot of unnecessary things by having a standard box, then maybe the hardware is costing more, or you're not able to dive in with the driver set as much as you like and use some of that hardware offloading that a lot of vendors are using. So I think there's still value in purpose-built hardware, but at the same time, you look at the cloud-hosted stuff, and there's definitely a place where just being able to load the software and get what you need out of it, subtract the hardware, is valuable too. So I don't know. I guess I see where you're going with it, but I don't know that the purpose-built hardware is going away.
Yeah. Oh well. Yeah. I mean, there's still. People are still making mainframes. Like old school mainframes. There's still a market for that. There's still people programming in COBOL, right? There's going to be a lot of people that are willing to just keep handing those guys money for the existing architectures and the existing way things work.
Actually, just about 5 years ago, you could have still bought new punch card readers. So it's like,
Yeah, I think I read that. Go ahead.
There's nothing that stops you from grabbing a PC and throwing a bunch of NICs in it and loading your own. Even if you just throw Linux on it and install all the necessary routing and firewall software, like you can do that, and you've been able to do that for a long time, years and years now. So I don't know.
Well, realistically though, is anybody that good with Linux and with kernel parameters? First of all, it requires massive amount of studying, massive amount of knowledge to properly turn a Linux into a networking appliance. And second of all, would anybody be comfortable deploying that in production?
Well, and I mean, you look at Juniper, and you look at Edge Router, and you look at Aruba Gear, and you look at all these vendors. They have a Linux kernel, right? They're taking that software. They've already figured out all the parameters they need to tune, and they've done that part for you.
Exactly.
So you're paying for something that's purpose built. It's using less power. It's it's the difference of you want a home server, and you can go out and you can buy a NAS these days that's very purpose built. It's low power. It has a decent processor. You can do different things with it. And maybe it's not as cheap as being able to put together your own little server, but when you build the server yourself, maybe it's going to use more power, or you're going to have to figure out a lot of those pieces of software. You can't just say, hey, I want a Samba file server, and you click the button that says type in the password you want to use.
Yeah.
Well, it doesn't mean that you can't build your own box.
I'm thinking too, like imagine a 1U network device that's 48 ports, right? Say it's, I don't know, let's just be easy. It's 48 gig ports, right? I can imagine somebody putting some off-the-shelf ASICs in there with a decent processor where you could load pretty much anything on there, right? So it's probably going to have way more horsepower than the average person listening to this podcast would be able to utilize. But I'm thinking, if you went out and bought a Ferrari right now, it's going to cost you an absorbent amount of money, right? But say Ferrari decided to go out and build, I don't know, 10 million of those cars and sell them out. I'm willing to bet the price is going to drastically drop to a point where, and say they don't ship with engines, right? You get to load your own in there. I bet it's going to be a pretty cheap chassis to buy All right, and that's kind of how I see this. Like,
But why are they going to do that, right?
right?
I mean,
No.
it doesn't make it necessarily cheaper for them. They are able to charge what they're able to charge because of what it is.
Well, I'm thinking there's got
It's not
to
a
be
Ferrari at the end of the day.
there's
if they can
got
sell
to
the kit.
be some monster Chinese factory that's spitting out tons of these varieties of equipment for other people. Why couldn't they just, spin up and chunk out 1 million of these white label
How do you
boxes?
think these small companies are coming up with their own switches right now, right?
Right, like the Natonics and stuff like that.
Sure, they're going and they're getting the hardware from somebody that's already doing that stuff, right? And they're loading their software on it. They don't have electrical engineers in-house that are designing the boards themselves and picking out the processor and all that, right?
Yeah.
Even board design these days is jokingly simple. Like, board designers, I don't want to, I know board designers are going to get mad at me at this point if anybody of them is listening.
What board designers are going to listen to this?
It's actually not, you don't have much freedom anymore, because when you are designing a board for a router, you are, everything is integrated these days. It's SOCs, right? It's a system on chip.
Yeah.
So you get the chip, and with that, from your chip manufacturer, you get a specification for the power input system and everything. So designing a board these days is not playing with individual capacitors, transistors, processor, memory controller, blah blah blah. It's basically, oh, here is my SOC, system on chip, and that already comes with its power distribution and then filtering system and all of that, and you basically assemble pre-built components onto your own PCB, and that's it.
You drop them in, the software even auto routes, right?
Yeah, exactly. It's all pre-built already by your actual vendors these days. So
yeah, and even there, I can't remember who they were talking about, but they were saying somebody took, I think with the Tomahawk or maybe the Broadcom chipset, and they completely ignored the drivers from the manufacturer and they just wrote their own from the ground up. Was that Juniper that did that? Somebody, I can't remember, but they rewrote from the ground up the drivers to work with their software even better, right? And they were able to get better efficiencies than the drivers that came from the chip manufacturers. So that's so true. I guess hardware seems less important these days. I don't know. And then why couldn't you just use some off-the-shelf power supply, right? So off-the-shelf power supply, you're using all of those integrated features inside those chips. Seems to make sense.
But when you're spending money as an end user, you need something that works. Like the WISP isn't going to go out there and figure out. I mean, I would say they used to figure out a lot more than they have to these days, right? Now you can buy a completely built radio. At one point, you buy all the equipment, you put it in a custom box, and you figure out your own power supplies and your own, You
assemble everything.
Used to be a lot more assembly, and the industry didn't stick with the assemble it yourself model. They said, hey, we can build and manufacture this purpose-built software and hardware, put it together in a finished product and sell that, and people are going to want it. And why do we have these shows where we have all these manufacturers that are building all this stuff that's the operator doesn't have to figure out the hardware and software and tuning and all these parameters, right?
True story.
Yeah,
go ahead.
Let's be honest. I mean, most of the network admins today just want to click one button and have things done. Like it's even in our debates, you can see it, that people complain, oh, Mikrotik, you need to click too many buttons, and it has too many features, and Ubiquitous, turn it on and done. So I think the whole industry is moving to just simplification of everything, and at some points that's bad. From some angles it's bad, from some angles it's good. So I feel as long as we have a choice, then it's okay. If people want to deploy one-click things, if people want to buy pre-built things, sure. But as long as we have a choice, right?
Yeah. And with that choice comes a lot of confusion, I think, too, right? So there really is no clear winner. So if I'm a brand new WISP and I'm like, well, there's all these different wireless manufacturers, and it seems like a new one pops up every so often, right? So you've got Mikrotik and Ubiquity are the old ones. Then you've got Cambian, right? That's more expensive, but I hear it's more solid. And then you have like the buy-sell stuff. Is that the LTE? And then you've got Telrad, which is some LTE stuff. And then, it seems like new vendors are popping up. fairly frequently, and it's like, how do I don't even know what to pick, you know? So even so you say that like things are getting simpler, right? So you don't have to assemble your own. Well, now everybody's coming out with a virtually identical looking product. And now that there's still the confusion, right? There's still the work you have to put in to try and figure out which one will fit your
It's not the
price
same
point
type
and all
of
this
work,
stuff.
right?
Yeah,
It's different.
You're figuring out which product best fits your business model, not how to tune the kernel on a custom built solution. You know, you're going to be in your garage doing a lot different. That's not their business.
No.
Their business is to provide
Entirely
internet
different.
to the end user. It's
Oh
not
no,
to
I was actually
figure
running
out how
down
to
a different.
manufacture.
I was running down a
Okay,
different
sorry.
tangent. I had left the building. Yeah. It's just I was thinking it doesn't matter where you go, what you do. We're always going to run into this confusion thing. Like, what do I even pick? There's never going to be a clear answer, right? There's never going to be one thing that everybody uses.
Well, and at the end of the day, why is Apple successful, right? They've picked everything for you.
Well, there's a certain set of people that just
This
need
is
to be
the
better
one
than
phone
everybody
you
else.
have, and this is how it works.
with one button,
With one button. Yeah, the Fisher Price phone. That's what they are.
you know, without the headphone jack, because obviously nobody needs that.
Of course not.
Right. And they've decided that for you. And a lot of people just say, okay, I don't want to have to figure this out.
I don't
want
need
the
a
thing
headphone
for
jack.
somebody else made the decision. Okay, you're right. I don't need the headphone jack.
Yeah, I don't know. It's all confusing. And I know one of the things that we really need to do is just have a cast on all the different, say, radio types and why people like what they like. But what I really like about those is each one of us is going to have a different opinion about different things. Some of us are going to hate one thing for one reason and love it for a different. And I think that's what kind of I love about this sort of environment is that everybody has different viewpoints, but that's also sort of terrifying, right? So say I was a WISP, I want to pick one product and feel confident in going with that, right? And all of us will crap on each product that somebody wants to go with for different reasons, right? So it's sort of potluck. And I've seen people start deploying one thing and wholesale have to change it later because it doesn't work in their environment or it doesn't work for their use case.
Well, and I think it's night and day difference too. If you're in a rural environment where you're having to do 20-mile shots and you're providing between sub 1 megabit per second and 10 megabit per second service versus somebody that's in an urban area and they're needing to compete at gigabit speeds, like the hardware you're going to use is completely different. It's a different business. And so just saying, oh yeah, this is the thing you need to go with.
It's like architecturing any other system, right? First you need to analyze and then you need to pick the right solution for the right use case, the right tools for the right job.
I don't know. Well, I mean, yeah, absolutely. I think you always have to analyze. And it's just one thing I'm thinking, not in the wireless world, but say in the regular networking world, you could conceivably pick Cisco and find a product that will fit virtually every situation, right? And it'll work. And it'll probably be reliable. But you could say the same for Juniper. You could probably pick a Juniper device and substitute it for Cisco and probably get it stable, right? And have it something that fits almost every environment. But in the WISP industry, I can't think of a single vendor that I would say, you know what, you can grab them and no matter where you go, no matter what environment, they're going to have a thing and it probably will work.
No, it just doesn't work that way for us.
Yeah, it sucks. It sucks. And it constantly changes, right? Whoever's on top in a specific environment today, 18 months from now, somebody else might really take over and have just a far superior product. And I don't know any other industry that gambles as much other than, going to Vegas to WISPAPALOOZA. Anyway, I think we've beaten that one about as much as we can. Wow, that one, we got a lot of mileage out of that one. I wasn't expecting it.
Tangent after tangent after tangent.
I love it. It's
Yeah,
fantastic.
at least it's good to know we still have that.
Yeah. You two guys were the ones I wanted to talk about the open compute stuff anyway. I figured you'd have some good stuff in there. All right, guys. So I think we've probably yelled at you enough, and hopefully you're all still awake. This is Wake Up Call. Just so we can say bye. Alex Hart, if you by chance wanted somebody to contact you out there on the interwebs, what's the best way to do that?
That is an excellent question that I don't have an answer to at the moment.
A smoke signal, perhaps? How about
Right.
how about through the Brothers WISP Facebook?
There you go. You're going to be the front man, right? I'll just send all my calls through you.
Alex Hart's office. Just a moment. Yeah, for sure. All right. Do you have any interesting things you have coming up in the near future? I know you're having another boy, right?
That's right.
All right. Congratulations, man.
Coming up next year.
I've got 2 boys, and they're insane. They're both completely crazy. So good luck with that.
Thank you.
Yeah.
I'm going to need.
You are. Thomas Kernack, if people want to get you out on the interwebs, what's the best way to do that?
Facebook, Skype, email. I'm pretty easy to find. Just Google for me, and you'll find ways to contact me very easily.
Yeah. Be sure to pop over to unimus.net, and that is, how do I spell that? unimus.net.
Yes.
Go find it. Jump on that sweet beta action. Anything interesting in your world right now?
Well, preparing for the London MUM, so we will be at the London MUM in November. So if anybody wants to say hi, just come over. We'll have a booth. And other than that, I think I'm gonna take a little break because the last 2 weeks have been just crazy. So yeah.
Sweet, man. Cool. Well, let's see. I'm Greg Soul. If you want to find me on the internet, gregsoul.com. I'm not very original. You can also find me at straightanet.com. That's the MDU ISP thing. You bring in the internet, I'll help you charge them and all that good stuff. The MDU owner can make a bunch of money because they are actually the ISP. I just do all the support, heavy lifting part. What else can I think of? The Nanog 68 in Dallas is coming up. I'm going to be there tomorrow. I'm going to be there tomorrow. I'm heading down tomorrow. Actually, I'm going to Austin first to meet a guy. And then I'm heading up there. I'm going to be there for a few days. If you're going to be there, be sure to grab me because I don't know anybody. Actually, a really nice guy named John Osmond, apparently it's Oz to his friends, emailed me and said, hey, if you still don't know anybody, I can make you a couple introductions. And he has done so via email, so hopefully I can run into those folks pretty soon. So super thank you to John. Maybe, I don't know, I haven't met these people. Maybe they're insane and I'll eat those words. But hopefully I'll see you guys. See somebody there, make some acquaintance. That would be nice. So I guess
Awesome.
This one's right at an hour, which is perfecto. If anybody wants to get a hold of us, again, grab us on Facebook. That's probably the easiest way. That is pretty much entirely run by Mike Hammond. He's the guy always putting up stuff on the Facebooks. So you got to thank him for sure. Be sure to look. There's a whole lot of WISPAPALOOZA videos that are up. I think they were doing some interviews and stuff like so. Be sure to jump on the YouTube channel and check all that out. And until next time, thanks guys. Leave us questions, comments, all that good stuff. I'd really love to do a question show, so throw a bunch of questions at us. And until then, thanks and bye.
All right.